Okay, we're going to get rolling here. Today we will talk about something of relevance to this class. Okay, so a couple of announcements. The class is just about full. I think you got an email from Student Services in Psychology saying as much, but there's like maybe 15 spots, and there are 15 junior and senior psychology majors still on the wait list. So the chances of getting in are dwindling to almost none. Now, it's not to say all psychology majors are going to get in because they need to get into one of the open sections. All this, I believe, should be resolved by Friday, though. So if you're not, if you've not been added to the class by Friday, I think then that means it's not going to happen. If you have any other questions, of course, see somebody in Student Services, and they can try to help you out. I keep trying to find out from our publisher when the books that they are sending me are supposed to arrive, and they're supposedly on their way, but they haven't arrived. And a couple of you emailed me about when are those copies going to be available in the library. Well, I hope they're going to get here today or tomorrow, or at worst next week. But in the meantime, I put PDFs that they sent me of the first 4 chapters on BSpace. There's a folder under resources, textbook chapters 1 through 4. So for those of you waiting for the books in the library, you can check out those PDFs. No, I don't think I will. Yeah. I don't even. Yeah, I'll just put them in education psychology. Sorry. Yeah. She asked if I could put one on reserve and Moffitt. But. All right. So a quote for the day today. Here it is. Where there's a will, I want to be in it. Thank you. Okay. That really has nothing to do with our topic, but it is funny. And remember that. No. So paradigms. This is what chapter 2 covers. It covers really 3 broad paradigms: genetic, neuroscience, the cognitive behavioral paradigm, and then some factors that cut across all of the paradigms that are important for understanding the symptoms, causes, and treatment of psychopathology. And that are 2 things: emotion and sociocultural factors. So I wanted today hit some of the high points and do some demonstrations for each of these paradigms and then the factors that cut across them. So first, let's start with the genetic paradigm. And here, you may still hear people asking, well, what is the cause? Is it genes or is it the environment? Is it nature or is it nurture? And in 2014, that's just the wrong question. You can't ask that anymore because we know too much now about how the genes work and how the environments work, and they always work together. So the better issue is, or question is, how is nature working via nurture? How do our genes work in combination with our environment? Genes are influenced very heavily by the environment. They can be turned on or off. It's called gene expression by different things that happen to us in our environment. And that's illustrated in both human and animal studies. Here is an example of a picture from our book. This is work done by Darling Francis, who's here at Berkeley in the Department of Public Health, showing with these cute little fellas here that the parenting style of rats actually makes a difference with respect to how genes are turned on and off. And a good parent here is somebody who does a lot of licking and grooming and what's called archback nursing. So that's in the rat world. That's what it takes to be a good mom. And the moms who do that, that increases gene expression in the offspring, so that their genetic profile looks different than little rats who don't have that kind of mothering. And that can get transmitted to the next generation. And if a rat finds themselves who doesn't in a family that doesn't have that kind of mothering, that gene is not going to be as influential. So something like basic mothering skills is influential in animals, but also in people. And this is also a picture that comes from our book here showing that people who grew up and were exposed to bad parenting in human terms, which is maltreatment, some kind of early abuse, whether that's physical, verbal abuse, any kind of maltreatment, you think, well, that's just a crappy situation to be in, and it is. But that alone doesn't increase the risk of somebody developing depression. Instead, it's a particular combination of a genetic allele that interacts with this particular environment of childhood maltreatment that increases the risk of developing depression. So if you have a particular combination, in this case, if you have one of the short alleles, it's called, of a particular gene, and there's lots of these gene-environment interactions, but this is one of the genes that has to do with the neurotransmitter serotonin. It's called the serotonin transporter gene. And if you have one of the short alleles here, this can, and you have that in combination with a childhood maltreatment, that's increasing the risk of developing depression 15 to 20 years later in adulthood. But having just that short allele in your genetic code is not sufficient to increase the risk of developing depression, nor is being maltreated as a child sufficient for increasing the risk of depression. It's the 2 of those together in humans that can increase the risk of depression. So when we think about genetics, we're not thinking about genes necessarily independent of the environment. We're always wanting to be thinking as we go throughout the course of the semester about how genes and environment interact, how they influence one another. Another thing to keep in mind is that when we talk about genes and the genes that have been associated with different kinds of disorders, ADHD, autism, schizophrenia, and the like, we're not talking about a single gene. There's not the one gene for bipolar disorder or the one gene for ADHD. There are many genes that are likely involved, and it's not just the gene per se having a particular gene or even an allele per se, but it could be a particular problem in the gene. And in genetics terms, a problem in the gene is often called a mutation in the gene. And there are particular kinds of problems in genes, mutations, hiccups, whatever word you can remember, that have been studied a lot lately in the realm of psychopathology. And those are in the book, and there are 2 different ones. One is called a SNP. Actually, that stands for, as you can see here, single nucleotide polymorphism. Who wants to say that? No one. So SNP is easier to remember. And SNPs, these account for probably 90% of the differences in genes in people, or genetic variation is sometimes referred to. So here, this is a picture that's also in the book illustrating the way genes are really constituted. They're all the same. So if those of you that remember from genetics, chromosomes, humans have how many? Anybody remember? 46, right? 22 pairs plus either an X or XY, the sex chromosome. And these are made up of genes. How many genes are in do human beings have? Anybody know? 20 to 25,000, a lot, a good bit. And the genes are made up of DNA, and the DNA is sequenced, or it goes in a certain order. There's another way of thinking about sequence here. And a SNP is a mutation or a difference, a hiccup in the sequencing of the material that constitutes DNA. So you can see that the nucleotides, there's only 4 of them, and you don't have to memorize these, but cytosine, thymine, adenine, or guanine, that's it. And they go in particular sequence. And I tried to illustrate here, in the top row, you can see that is the sequence that most people might have, but in the bottom row here, you can see where there is usually an A in the sequence. In this particular person, there's a G. So these things are, again, they account for when there are differences between people and genes. 90% of those differences are based in these SNPs. Now, that said, 99% of all of us, our genes are the same. 99%. But that 1% where we might have these differences can make a huge difference. And in these particular SNPs can make a difference in all sorts of genetic variation, but of course we're most interested in the variation in psychopathology. So these are heavily studied now, and we'll read about SNPs throughout the course of the semester here. Just try to remember here, you don't have to remember the 4 nucleotides or what SNP stands for, but remember that this has to do with a disruption, a difference difference in the sequencing of genes, of the nucleotides in a gene. It's a difference in the sequence, and these are the most common source of genetic variation. Now, another kind of thing that we'll read about, another hiccup or a problem in genes, is referred to as a CNV, or a copy number variation. These are rare, actually. So this accounts for only about 10% of genetic differences between people, or genetic variation, as it's referred to. So they're more rare than SNPs. A copy number variation is an abnormal copy of DNA within a gene. And so I've illustrated here, and there are two different kinds of CNVs, and this is an illustration of an addition. So if you see the gene on the left and then the gene on the right, there's an added copy of a particular segment in the structure of the gene. So CNVs refer to the structure within a gene, the structure of it, and there can either be an addition, something extra added in there, or there can be a deletion, something in the structure of a gene has been deleted. Why? Well, that's what scientists are trying to figure out right now. There's been some hiccup in development in prior environmental exposure that may contribute to this particular mutation or difference in a gene, whether it's either a deletion or this addition. So these are also being studied in psychopathology, the locations of particular genes and the kind of copy number variation, whether it's an addition or a deletion. So you're going to see these throughout the course of the semester. So again, this is not a class in genetics. What I'd like you to just remember is that a CNV refers to some sort of difference in the structure of the gene, whereas a SNP has to do with the difference in the sequence of the gene. SNPs are far more common source of genetic variation. These are more rare, but yet they have been studied, and we'll read about these in autism, for example, and schizophrenia. All right, what about the neuroscience paradigm? Here, we'll be talking a lot throughout the course of the semester about different neurotransmitters. You'll hear a lot about dopamine. You'll hear a lot about serotonin. You'll hear some about GABA, which stands for a long word. Acronyms are typically easier to remember than the long things that they stand for. You'll hear a little bit about norepinephrine. These are all substances in the brain that are communicated with neurons. Neuron transmission is signaling changes in the way these neurotransmitters work throughout the brain. You'll hear about different receptors. So that's what's illustrated here. The little bluish, purplish, I'm not sure how they look to you, dots are representing the neurotransmitters that are in neurons, that neurons may fire and release particular neurotransmitter that then may bind to a receptor on a different neuron. That's how they communicate with one another. So you'll be learning a lot about receptors. Particular kinds of receptors are important for understanding how some medications work. The mechanism of action of some medications that people take for schizophrenia or for depression. We'll learn about how these are working in the brain at the level of particular kinds of receptors. And then you'll also hear about another process in neurotransmitters called reuptake, which is particularly important in understanding how antidepressant medications work. And the process of reuptake is that a neurotransmitter, a neuron sends a signal to release some neurotransmitter into the synapse. The synapse is the space in between two neurons, so neurotransmitter is released into that space, and then it is taken back up into the neuron that just released it. Now that may sound like a very inefficient and silly sort of a mechanism for our brains to have, but it turns out it's very important. So a neurotransmitter is released, and then it's like, oops, I didn't need to go, and it comes right back into that neuron. And that's an important process in the genesis of many neurotransmitters, and one of the things that medications to treat depression do is they work on that particular process. You may have all heard of SSRIs. I don't know if anybody knows what SSRI stands for. Selective serotonin reuptake inhibitor. See, it's easier to say SSRI, but it's helpful to know what that means. So selective serotonin, selectively working on the neurotransmitter called serotonin, reuptake inhibitor. So that medication is inhibiting, stopping the process of reuptake of the neurotransmitter serotonin. That's what an SSRI is, and that is correlated with improvement in depression symptoms for some, not all, but for some people. So we'll talk about reuptake quite a bit. In the neuroscience paradigm, of course, we'll also talk about the brain, and I do want you to know, broadly speaking, not everything about the brain. We're not a neuroanatomy class, but I want you to know particular structures of the brain. We're going to talk an awful lot about the frontal lobes. This big section of brain real estate right here, on the top of the head, really up to right here. This area of the brain is associated with problems in all sorts of disorders that we'll talk about. ADHD, schizophrenia, depression, bipolar disorder. Lots of the disorders we're going to talk about, we're going to be talking about the frontal lobes. We'll probably be talking less, but a little bit about temporal lobes, and not very much about occipital lobe. It's the back of the brain that's associated with our ability to see things, and the parietal lobe kind of back here is associated with our ability to sense things, smell and movement in particular. We'll talk about Parkinson's disease, we can talk about the parietal lobe. But we'll also be taking a look, this is called the cortex of the brain, the outer surface of the brain, and these different lobes of the brain. But we'll also be talking about the inside of the brain here. So if we peel away and look inside the brain, these are called subcortical structures underneath the cortex, and these are some of the things that we'll be revisiting over and over again. Things like the hypothalamus has been studied in eating disorders, for example. It doesn't seem to play a role, but it was an obvious go-to thing to look at since it's associated with regulating things like hunger. The amygdala is an area of the brain that is associated with emotion, but not just emotion. Anything that is salient or important or something that captures your attention, your amygdala is going to respond to that. And so we'll talk about that in disorders like depression, for example, and bipolar disorder, and anxiety disorders. We'll also talk about the hippocampus. This is an area that has been studied in many studies of memory and our ability to remember things, and why can we remember some things and not others? What brings things to mind? Why can't we retrieve things? Why don't we encode things properly? So we'll talk about memory issues and the role of the hippocampus in a lot of disorders, for example, like PTSD, post-traumatic stress disorder. So I do want you to know these subcortical structures as well. They're going to pop up over and over again. One thing to remember about the neuroscience paradigm, and particularly with respect to the brain, is that we've known since, if you remember when we talked about the history, since the 1800s, when there is damage to an area of the brain, there's a behavioral consequence. And so that's when people got areas of the brain named after them, Broca's area, for example. But what people don't recognize as readily is that our behavior influences our brain all the time. Our behavior can also change our brain. And I'm not just talking about like drug-taking behavior, for example. Of course, that can change your brain. But the kinds of environments, the kinds of emotional responses that we have can actually change our brain. It happens all the time. We know our brain is now much more malleable than we once thought. We used to think that the brain, once you developed and you had a completely developed brain, sometime in adolescence, you were done, and that was it. We now know the brain is very plastic. I don't know if you know the term. That's a term you'll see a lot in neuroscience. So plasticity in the brain, it changes all the time. And things that happen to us in our environment change our brain. Just as much as changes to our brain can change our behavior. I saw you had a question. So. No. So his question is, if somebody showed no signs of schizophrenia, but then had trauma to the frontal lobe, could they suddenly wake up one day and have schizophrenia? And the answer is no. You could have some other behavioral problems. They wouldn't probably look too much like schizophrenia that would result from trauma to the frontal lobes, but it wouldn't necessarily look like schizophrenia. And it wouldn't be things like hearing voices, which is something that happens in schizophrenia, or having odd beliefs. Your emotional responses might completely change. And one of the famous historical cases of damage to the frontal lobe was the case of Phineas Gage. Has anybody heard of that? Phineas Gage was working on a railroad. There was an explosion, and a tamping rod that was used to tamp down dynamite went right through the dude's head, right here, came right off the top. And when it happened, he was like, well, I was there, nobody was. But you can imagine the way it was reported. It was like, wow, that was weird. Like something just, hit me in the head. He had no idea that a whole thing shot through his head. And he survived this injury, even though there was not much, good medicine necessarily at the time. He survived this, but he underwent a profound change in personality. He was no longer Gage, is what a famous quote that came from him. And we've known, and his brain was preserved throughout time. It's still available. In fact, I could find this on a nice website and YouTube videos of people looking at his brain to really try to understand where the damage was. And it involved a lot of what's called the orbital frontal cortex, which is the area of the frontal lobes, but kind of right behind your eyes and above your nose. Took a particularly big shot from that rod shooting right through his head. All right, let's switch now and hit some highlights from the cognitive behavioral paradigm. So let's start with the behavior side of the cognitive behavioral paradigm. Remember we talked about history and Skinner in particular, and the idea that behavior is reinforced by consequences. And so we'll talk about this a good bit. If you want to change somebody's behavior, you change the consequences. So things that you've probably all heard of before, telling people a good job if you want them to keep doing something. So someone is running and they're tired, they want to stop, I'm too tired, you're doing great, you're almost there, you can make it to the finish line. You're kind of giving them some praise to help continue their running so they can make it to the finish line. Timeout is a behavioral procedure that many parents use as a way of trying to decrease kids' negative behavior. So you may have experienced this yourself, as a child. If you throwing a tantrum, mom and dad say stand in the corner, sit in the chair until you can be calm. Okay, you're trying to change the tantruming behavior by putting the child in a different environment, and you're not rewarding that tantruming behavior by soothing or telling them it's okay or waiting it out. The calendar here, what does that have to do? Well, this is something that Apple uses magnificently. Whenever there's going to be a new Apple device, an iPad, iPhone, which probably could be coming out to the 5S, sometime, they'll give you a little, how many days are coming, kind of building anticipation here to alter your behavior, because from Apple's perspective, they want you to go out and buy a new device. Doesn't matter if you just bought one 6 months ago. The new one is going to be better. So modifying people's behavior by altering consequences. A good example of this, but it has nothing to do with psychology, but I like to do it because it involves my dog. This is Biscuit, golden retriever when she was a puppy. Isn't that cute? So puppies are cute. Who doesn't like puppies? I mean, some people don't like dogs, all right, I grant that. But for the most part, puppies are super cute, and you like to get on the ground and wrestle with them, and they like to jump all over you and nibble on you, and that's really super cute when they're little. But when golden retrievers grow up, they tend to weigh anywhere from 50 to 85 pounds, and it's not so super cute if they're jumping up on you and crawling all over you. So you want to change a puppy's behavior. You want good behavior. Teaching your dog to sit. So sit, Biscuit, and then she sits, and then I give her a reward, and that helps. Positive reinforcement is what this is called, increasing the likelihood that she will sit in the future when I tell her to sit. Now, what does that have to do with psychology? Nothing. But the concept of positive reinforcement is something that will come up when we discuss particularly some sorts of treatments for different, particularly childhood disorders. Negative reinforcement is the perennially confusing concept here. So I don't know how to help you remember this other than by some examples here. But the goal of, if you want to reinforce a behavior, you want that behavior to continue here. And so, but what makes negative reinforcement confusing is that it's usually the term negative, because you think, well, you want to decrease the behavior. No, you really want to increase the behavior, but you want to strengthen a behavior that isn't so negative. So seatbelts are sometimes a good example. When you get in your car, you haven't put your seatbelt on, you hear that annoying beep, 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 beep. And what does that do? It kind of compels you to fasten your seatbelt. And that's what that's doing through a negative reinforcement process. The aversive sound is negative. You want that to stop. But what you're really doing, you're increasing the likelihood that you're increasing the behavior of seatbelt wearing, which is the whole purpose of that, to increase that behavior by the removal of something negative or aversive. In this case, a annoying beeping sound. This is on the slide too, is another way of demonstrating how reinforcement works not only with the child but with the parents. This is parents' worst nightmare. You're in the middle of a grocery store and little Sally breaks down and sits down in the produce aisle screaming, that she must have breaks, and she will not budge, until she gets a break. Now, what, parents are mortified, they want to get their shopping done, they're looking around, other people are looking at them like, what are you, the worst parent in the world, give your kids a break. So parent gives in, and then Sally is happy, she stops, crying because she got, her breaks. So what are we reinforcing in that instance? Tantrum. So next time you're in a grocery store, Sally may, realize that if she wants to get something, if she throws a tantrum, mom or dad are going to give in here. So the child learns to throw a tantrum, but the parent is also actually, their giving in behavior is actually reinforced, right? Because the tantrum, loud, aversive, other people staring, calling attention, I want that to stop, and so they give in. So they solve one problem, stares go away, crying stops, but that another one, has just been hatched, because now little Sally has learned that she can get what she wants by throwing a tantrum. Now let's switch to the cognitive side of the cognitive behavioral paradigm now. Here, people study things like, and I believe I mentioned this Tuesday, things like attributions to what do you attribute something happening. Attribution is another word for cause. Why do bad things happen? And people with depression, for example, make particular attributions about why bad things happen. They're different from people who don't have depression. Cognitive science also now is studying the unconscious. If you remember from our history lecture, behaviorism rejected the ideas of Freud and psychoanalysis, and the unconscious can't be measured. It's front and center now in many, many cognitive neuroscience studies. Memory. Why is it that people with anxiety, for example, have a tendency to remember threatening things that are associated with things that they're anxious about more so than other kinds of things? They tend to have some literature sometimes calls this a bias towards remembering threatening things compared to other things. So memory is